Sir,
Yes, yes.
sir, you gave us some last week that advanced answer. I got that answer.
Good. Others also got that. I tell. Anushrita and Adrita, both of them answered that. Anyway,
Sir,
good.
the answer is 8.
Yeah, answer is right.
Yes, I also got the answer.
Yes, sir,
Great.
8.
Yeah, brilliant. All of you are young prodigies. In 9th class, you are solving advanced questions. Okay. So I was going through your feedback forms and quite useful. One of the feedback which one of you said you wanted to know what are the topics that are going to be taught so that you can prepare before the class. This was on feedback. So I thought I'll just share the schedule, like the flow of the syllabus. Is this okay? You're able to see this?
Sir,
Yeah. If you
so
want,
one second.
Yes, sir.
Just a second. So just a second.
I can mail it. Don't worry. I can mail. I wanted to. First of all, this is a tentative schedule. Okay. Tentative log. Tentative syllabus log. Okay. I think this would cover both your CBSE and ICSE syllabus. Okay. And second of all, when I say tentative, I mean some we can have some extra topics. Some extra topics based on the circumstances and circumstances.
Sir, can you send
Yeah.
in the mail?
Yeah, I'll send it in mail. Don't worry. Okay.
Okay, sir.
So one more thing is there. See, some of the topics I'm doing on Monday. I'm taking the advanced class on Monday, right? So I don't know if everyone is fully aware. So this advanced class, basically, I told I'll cover the syllabus of class 11. So I'm not pressurizing anyone to join. See, because naturally some of you will be taking more interest in other fields of science. Some of you might go towards commerce. Some of you might take arts. Some of you might be interested in something else. So I don't have any pressure. But if someone is particularly interested in engineering, or you know that you want to crack some exam like BITSAT or JEE, or you want to crack this ISI exam. So if you have such aspirations, then I recommend that you attend advanced class on Monday. So till now we have had 3 classes in which we completed set. So even though we did that there, don't worry, we are going to do that in our general class also. Okay. So there's nothing to worry. And one of you gave feedback that you thought that the class was little short. Class is not short, it is 1.5 hours. And I don't want to stretch it beyond 1.5 hours. Then you might ask, sir, we should have more classes. So that's what, instead of having more classes, I created the provision of this class on Monday. So
Please, sir.
Yes, Arthur.
So we also can participate in the extra class.
See, I told anyone can participate. Na? It's not limited to anyone. I told whoever is interested can participate. Right? So, but the thing is that portion is relevant to class 11th. See, naturally, na, everyone won't be comfortable learning something so extra. All of you are from different school. All of you have different appetite. And it is not, see, I'm telling you, it is not that you're attending the class, that means you're much better than others. It is not true. Because I personally studied in Narayana. I'm from Narayana College, where most of the people are like that. They have studied 11th, 12th syllabus in school itself. But then I was from other school. I did not study much, but then I saw most of us were able to crack the exam, and many people who studied this in school, they were not able to crack. So it gives us small advantage, but then it is not that if you don't take this class, then you have no hope, you're in big trouble, nothing like that. if you are interested, if you have the time, if you have the capacity, then you're welcome to attend this class. Okay? Because anyway, I told it is something relevant to class 11th. It might not be relevant also to your school syllabus. Whereas this class, it will be very much relevant to your CBSE, ICSE, and competitive exams. See, all the topics which are relevant to competitive exams will be covered here. For example, here you'll have trigonometry. Where is trigonometry? Trigonometry. And here we'll be having geometry. Where is geometry? Geometry. These are very, very important topics. Trigonometry, geometry, and you have coordinate geometry. So we are going to cover all these topics. Now, another thing is, though the schedule is made in this way, based on the situation, I might cover some topics earlier than the other. Okay, I'll let you know if I cover them. And I'm giving some topics like commercial mathematics a lower priority. You can see all these commercial mathematics topics are put in the end. Okay. Because one thing is, they are more relevant to people who are interested in commerce, which is very good, but still, so I'm giving it a priority. We'll do it later on. Okay? I'm not giving it top priority as of now. But one more thing is that if someone has any problem in school, they're doing their school mathematics and they're finding some difficulty, you can feel very free to approach me. Some students are already asking questions. I'm happy. So others can also mail. If you have any doubts in your school syllabus or you come across any questions, feel free to ask. Okay. And everyone can benefit. If you ask in class, or if you have a doubt, you can personally ask me on mail.
Sir,
Okay.
can I ask you one thing, sir? So, what are the good books for competitive exams? Suppose mathematics or science, generally.
Yeah, one more thing. In the feedback, some of you are also asking about material. See, whatever chapter I teach, if material is required, I'll give you material. Okay, from our institute side, we'll give you. So last time I gave material for logarithms. I don't know how many of you went through that material. That was very elaborate material. One second, I'll just show you the material.
Sir, you sent it mail.
No, we put it in a WhatsApp group as far as I remember, for everyone. Did you get it? Yes or no? Logarithms chapter. You guys did not get it?
No,
No, sir.
no, sir, no, sir.
No, sir.
No, sir. We did not get.
No, sir, we didn't get it. Not yet.
Oh, this logarithms you guys did not get?
No, sir.
No,
Sir,
sir.
you sent
No, sir.
sets, but not you sent sets to our mail, but you did not send log.
No, set is last week, but logarithms is 2 weeks ago I sent this. You did not get?
No, sir.
No, sir.
Okay, fine. So, okay, I will share this also with all. Fine. I'll share the schedule and the notes on logarithms, right? Anyway, so let us come to today's topic. So today we'll be doing polynomials. We are going to start with polynomials.
Sir,
Yes.
so can you show the solution of that answer? I didn't get. I mean that question.
Oh, okay.
So can I answer?
No, I'll
But
just do
can
it.
I answer?
I'll just do it quickly.
So
Okay.
can I answer?
I'll answer if required. I'll ask anyone else. Okay. Because I want to quickly start the next one. Okay. So this one, right? Yeah. So you are supposed to use this hint, and on using this hint, you can solve it. For example, first part.
Sir, I can do this.
Yeah. Wait. If required, I'll ask. Okay. So let us say this is A and B. So we want to solve A into B. Now you see part A can be written in this way. Okay. See the part A is log 9 to the base 2. Right? It is whole power 2, whole power something else. Now in exponents and powers, A power m whole power n. This is equal to A power m into
Amen.
yeah.
I'm into it.
Yeah. Similarly, here you have log 9 to the base 2 power 2 whole to the power something else. So naturally, this would become 2 into 1 by log 9 to the base 2 to the base 2. Okay. Now, just to avoid confusion, I'm going to do this step. Let us assume that this is called k. If this is k, then can I say that this is also k?
Sir, I did it this manner only. I took it as a variable x.
Yeah, fine. So if this is k, then this becomes k power.
From the beginning, I can't understand.
Yeah, just do it. This is the beginning only. This is log k to the base 2. See, I just started. Which part did you not understand? This is log 9 to the base 2, 2 whole power this. I just wrote this part. Okay, yes, sir. This part, I am expanding this part. And if this log 9 to the base 2 is equal to k, then a can be written as k power 2 by log k to the base 2. Now, if you remember, there is a property where 1 by log k to the base 2 becomes equal to log. What
2
is it?
to the base k.
Base
Log
k.
2 to the base k.
K.
Okay. So this is equal to k power 2 into. So instead of 1 by log k base 2, you are supposed to write log 2 to the base k. But what is 2 into log 2 base k? It is k 2 square log k.
Yes, sir.
Okay. Here, Sarkar, can you tell me what is this equal to? K to the power log 4 base k. K to the power log 4 base k. What is this equal to?
Sir, can I tell?
Let here tell. Here, Sarkar.
So 1. Oh, sorry, 4.
4, yeah, good. Okay. So this becomes equal to 4. You're fine. K log 2 square. 2 square is 4 to the base k becomes. So this A part is actually equal to 4. Similarly, Ashmita, can you try the B part yourself? Ashmita?
Sir, it will be 8.
Yes. But
So
Ashmita,
I can't understand this whole part.
which part?
This whole.
Whole.
Yes, sir.
Whole means we are
From the
assuming.
beginning.
See, if this is A, I simplified A in this manner. If this is A, then I'm writing A is log 9 to the base 2 whole square, whole to the power something else.
Yes, sir.
So I simplified that. See, the same thing I wrote like this: 2 by log 2 k. This A part, can we write it in this fashion? Yes or no? Did not understand?
No, sir.
See, if I assume that this log 9 to the base 2 is k, then can A part be written like this: log 9 to the base 2 whole square. Where is this 2 going? It is going over here. Okay. And in the denominator, what do you have? You have log of log 9 base 2. What is log 9 base 2? K. Log 9 base 2 is k. Is that okay? You
Yes,
are
sir.
understanding? Ashmita, are you understanding?
Yes, sir.
Yeah. And then this 2 is the base. Same base I'm writing here. This is okay? Is this okay?
Sir, I'm solving
Yes.
the B part. I got the A part, I'm solving the B one.
Uh-huh.
I got the A to solve the B part.
Okay, but here, Sarkar, you understood?
Yes, sir.
Oh. So now 2 by log k base 2 can be written as 2 into log 2 base k. This you understand? 2 by log k base 2 can be written as 2 into log 2 base k. Yes or no?
Yes, sir.
So,
So 2 into log 2 is nothing but 2 power 2. Remember this property. 2 into log 2. Like m into log a becomes equal to log of a power m. So 2 into log 2 becomes 2 square. Is that okay?
yes, sir.
So this becomes k power log 4 base k, which is nothing but 4. You yourself too. So this a part simplifies to 4. Okay? Is that okay? Here, Sarkar?
Yes, sir.
Yeah. Now I want you to try B part by yourself at home. Do it later because now we're short of time. Okay. Try the B part at home. If you're not able to get, we'll discuss later. All right.
Okay.
Right. Polynomials. Can we start? Can we start polynomials?
Yes, sir.
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
Okay. Thank you. That is enough confirmation. So what do you mean by poly?
Sir,
Poly.
more than two.
More than
More than
three.
2, 3.
Many.
Sir, more
Poly
than
means-
three terms.
Fine, fine. Poly means many and nomials means terms. So the literal meaning of polynomials means many terms. If you have many terms, then basically you have a polynomial, right? Now, what is the definition of a polynomial? So for ninth class, now, a very simple understanding of a polynomial would be as follows. Definition. You can note the definition. A polynomial, a polynomial, a polynomial, a polynomial is an expression. A polynomial is an expression of the form a naught plus a1 x power 1 plus a2 x square plus so on till an x power. Okay. So any polynomial is of this form where a naught a1 so on till an are real numbers. Where a1, a naught, a1, a2, a3, so on till an are any real numbers. Okay. And and n is a non-negative. N is a non-negative integer. N is a non-negative integer. Okay. So a polynomial in one variable. So this is a polynomial in one variable. What is a variable here? What is a variable in this?
The X.
X, sir.
Sir, X.
Yes. Okay. Good. So we see that this is a polynomial in the variable x, and a naught. See, sometimes students get little afraid when they see so many unknowns. But see, these are just some numbers. A naught, a1, a2, an. They're all just numbers. Now I'll write some numbers. Tell me if it's a polynomial. Hmm. Okay. So you guys tell me which of the following are polynomials, which are not polynomials. First one, is it a polynomial? Yes or no?
No, sir.
No, sir.
No, sir.
One second. I think I have. Okay. Yeah, let us come back. First one, is it a polynomial? Yes or no?
No, sir.
No, sir.
Why not? Why not?
Sir, because here the
Yes,
power
sir.
of 3
It
is
is
half.
polynomial.
Wait. See, what you do from now onwards, anyone wants to answer, you raise your hand up. Shrujita can answer. Shrujita.
Sir, you told the definition that a polynomial is an expression of the form. You gave the expression, then you wrote that where a naught, a1,
Come to the
all
point.
these are real numbers, and n is a non-negative integer. But here, sir, in the first expression which you gave, x square minus root 3. Root 3 has sorry, sir, 3 has the means power of 1 by 2 half. That's why it's not a polynomial.
So it is.
Wait. Let me answer. See, an expression of this form. See, what is supposed to be a non-negative integer? N, the power of x. The power of x is supposed to be a whole number. You get it? This non-negative integer n, this is corresponding to the power of x. It is corresponding to the power of x. So this is a constant term, na? So whether its power is whole number or not whole number, it is okay. You understand? Shritita?
Sir, your voice is cracking.
So yes, your voice is cracking. I can't
Your
hear.
voice is cracking and some background noises are also coming.
Yeah, it's echoing.
So then I'll mute everyone. Yeah. So what I said that this n. See, she is telling that, sir, it is not a polynomial. Why it is not a polynomial? Because she is telling, sir, because root 3 is 3 power half. But in the definition, no such mention is there. It is told that a0 plus a1 x power 1 x square, so on and so forth. This n should be an integer. But what is n? N is the power of x. See here, what is the power of x? 2. And 2 is an integer. There is no problem with that. So this term is satisfying the definition. Now what about the second term? Now the second term is root 3. Is root 3 a real number? Yes or no? It is a real number. Now according to the definition, this a0 part, it should be a real number. Because here written a0, a1, an, everything is a real number. Getting? So root 3 is a real number. The exponent of x is 2, which is a non-negative integer. So what is the problem with this? So that means this is a polynomial. You want to tell something, Srijita?
No, sir, I understood my mistake.
Okay. Second one. Who wants to answer the second one? Is it polynomial or not? Second one. Anyone wants to attempt?
Sir, it's not a, it's a polynomial.
Okay. Raise hand. First you should raise hand. Okay. So tell me, Swapna, with anyway you told.
It's a polynomial.
Okay. Why
So
is it?
because
Oh.
here the x, which is this type of thing, x has a power of
Huh.
3, which is positive,
Okay.
and root x, which is the constant. Here it means it will be a not a constant term, but it does not has a power of any negative type of integer.
But is what is this x power how much?
X to the power half.
So is this a non-negative integer?
Yes, sir.
Oh, sir.
Is this an integer?
No, it's not an integer, it's a fraction.
Then, so can it be a polynomial? Huh?
Yes, sir.
No, this is not a polynomial. Okay, fine.
Sir, why?
Y means root x. See, the power should be a non-negative integer.
Oh, sir, for a variable, not for a constant.
Yeah, but x is not a constant. No, x is variable only.
So now I understood it. Okay. Sir, when you told that one, I thought that variables also come in that. Okay, sir. Only constant can have a power of a negative, fractional power or a negative.
Constant is constant. Who cares what it is? Root 3 is a constant value, na?
Yes, sir.
It is a real number. Okay. But now root x is not a constant. It is a variable. What is the
Yes,
power? Power is a fraction. So this is not integer. Therefore, the second one is not a polynomial. Okay. Anyone has any doubt? Okay. Swapnavit, you have some doubt?
Sir.
Yes or no?
No, sir, not clear.
Adrita, you have doubt? Unless you don't have doubt, don't raise hand. Okay, fine. So third question. Who wants to attempt third question? Third one. Any participants for answering third one? No one. Only Pawan, Srijita. Okay, Srijita. Go ahead.
It's a polynomial, I think.
Good. Why? What is the reason?
So because here all the conditions are satisfied for it to be a polynomial, and no negative n is not negative also, and everything is satisfied.
This term is in no violation. X square, x power some non-negative integer. This is also a non-negative integer, x power 1, 5.
Yes, sir.
This is a constant.
Constant,
Yeah.
yes.
Yes, it's a constant only.
Yes, sir. It's a constant.
This is an irrational number. But
So,
irrational,
but real numbers also consist of irrational numbers, na?
irrational numbers are also a real number. So it's not a problem. Is it okay?
Yeah. Yes, sir.
Okay. Fourth one. Anyone wants to attempt fourth one?
Sir, can I?
No, raise hand, raise hand. Adrita.
Sir, I raised my hand.
Yes, Adrita.
Sir, it's not a polynomial.
Why not?
Because sir, the degree of x is the degree of x is not a non-negative integer.
Yeah. See, this is not a non-negative integer. Therefore, this is not. Okay.
So,
Yes.
so can you explain the second one again?
Second one. See, x cube plus x power half. This is the second one. Okay. So this term is okay. X power 3, and 3 is a non-negative integer. But is half a non-negative integer? Half is not an integer.
Yes, sir.
Anushrita.
Oh, okay, sir.
Okay. Now fifth one, raise your hand. Fifth, who wants to tell? Raise your hand. Raise your hand for fifth. Okay. Swapnavit. Yes, Swapnavit.
Sir, we. Sir, oh.
Arey, after thinking you should raise hand. You should not raise hand and then start. Anyone is ready? Anushrita, you tell.
Sir, can I?
Anushrita.
Sir, I'm ready. Sir, I'm ready. But I'm just asking the question.
No. When I ask question, you should answer. You should not ask me a question.
No, sir, I am not asking you a question.
Okay. Go ahead.
Sir, I am asking which question. I was not able to hear you properly.
Arey, after what comes?
5.
Good, correct. Now answer. Fifth question.
Sir, here we have x plus 1 in minus. So we'll simplify the brackets first, which will be equal to x plus 1 minus x plus 2, then minus 3. From here we know there is no variable here. We get to know.
Answer, tell me. Polynomial है या नहीं? Is it a polynomial? Yes or no?
Sir, answer is it's not a polynomial.
Okay, wait. Why? Because there is no variable term. That is your answer. Okay. है ना? Okay, done. Next. Here, Sarkar.
Yes, sir. So we know that the variable x square have the power of 2, and in the second term.
Fifth question. We're doing fifth question.
So fifth question. In the fifth question, we have first we have x plus 1 in the bracket, and then minus x minus 2 plus 3 and in the bracket. So first term, that x plus 1 in the bracket have no power. It means that the power is 1 and 1 is a whole number, so therefore it is a polynomial. And in the second one, x minus 2 plus 3, it is also in a bracket, and it doesn't have any power, so it also means that the power is 1, so therefore 1 is also a whole number, therefore the fifth one is a polynomial.
May I ask something?
Okay, wait. Who wants to ask?
Me, Srijita.
Yeah, but just before that, what Pawan Sathik wants to tell? Pawan.
Sir, I think it's a polynomial, sir.
Okay,
Sir,
done. Wait. Now tell me, Sujita, what you want to ask?
Sir, I was asking whether it is necessary that a polynomial will have a variable.
Yeah. So is it said now whenever you have any problem in life, always go back to the foundation, basic principles. Okay. Not just life, maths also. Anytime you are facing any difficulty in any question, go to the foundation. Go to the foundation, go to the principles, go to the definition. That's very important. Go to the definition. Now you tell me, a polynomial is an expression of the form a0 plus a1 x power 1, a2 x square, a1, so on. Now you tell me, I'm asking a question. Let us say if a not a1, a2, an, let us say all of them are 0. Can all of them be 0? Is there any problem? 0 is a real number, yes or no?
Yes, sir.
yes, sir.
So
Yes, sir.
if all of them are 0, am I violating any condition?
No.
No, sir.
No, sir.
So it is still a polynomial because I'm not violating any condition. Isn't it? Moreover, is that okay? Because
Yes, sir.
I'm not violating
Yes, sir.
any-
Yes,
Yeah. Moreover, such a polynomial.
yes.
Yeah. A polynomial 0 is known as 0 polynomial. 0 polynomial. And let us say it is a constant term, 3. This is known as constant polynomial. Or 3 pi whatever. But let us say you have x power 1 plus some 4, which is x plus 4. If the degree is 1, it is known as linear polynomial. If the degree is 2, let us say x square.
Quadratic polynomial.
Yeah, x
Quadratic.
Yeah, at x plus, let us say some pi x minus root. This is known as quadratic.
Quadratic polynomial.
Yeah, and if it is 3, it is called as.
Cubic polynomial.
Cubic polynomial.
If it is 4, it is called as.
Biquadratic polynomial.
Biquadratic.
Biquadratic polynomial.
If it is 5, it is called as. Okay. So I also don't know. You can check it and tell me. Fine. So now you tell me in this fifth question, x plus 1, and actually this is also x plus 1. So ultimately both of them cancel out and you get 0.
Yes, sir. We get minus.
0.
You get 0.
So yes, sir.
So is it a polynomial?
Yes, sir.
Yes, sir.
What polynomial?
Zero polynomial.
0 polynomial. Yes, sir.
So this is also a polynomial. Everyone is okay?
Yes, sir. That's why I was asking that question.
Yeah. Good. Okay, sixth question, last question. Raise your hands. Anyone wants to answer? Last question. Last one, anyone wants to answer? Okay. Ashmita, can you answer last one? Ashmita. Ashmita, are you there?
Sir,
Yeah. Can you answer this last one?
sir, I think it's a polynomial.
Okay. Why?
Sir, because if we move from this beginning, then a root 3 has the power of 3 to the power half. Then x, which is a variable, it also has the power of 2 plus 1 by x, which means that x has a power of minus 1. So I think it's a polynomial.
Uh-huh. Yes,
Sir,
Ashmita.
can I try?
Wait. Ashmita, so what is your conclusion?
Sir, I don't have any confusion. I'm just answering your question.
Yeah. My question is it a polynomial or not?
Sir, I think it's a polynomial.
Okay. Why do you think so?
Can
Because
I say?
x.
So it's not a polynomial.
It's
Wait,
not a
wait.
polynomial.
It's not a
Yes, sir, it's
polynomial.
not a polynomial.
Let her
Sir,
complete. Ashmita, so x power 2 is there. This is fine. What about this term?
Sir, it's x to the power minus 1, so it's not a polynomial because
Not a,
we cannot have a negative integer as our exponent.
therefore, this is not polynomial. Okay. Okay, everyone is clear with the basic understanding of what is a polynomial, what is not a polynomial.
yes, sir.
Yes, sir.
Sir.
Now, while we were discussing x power 1, x power 2, x power 3, there is a particular concept I thought I should teach, which is known as a degree of a polynomial.
Degree of polynomial.
Okay. So what do you mean by the degree of a polynomial? So write down the highest power of the variable, the highest power of the variable in a polynomial, of single variable, the highest power of the variable in polynomial of single variable is its degree. Okay. Now write a note. For a polynomial now for a polynomial of more than one variable, the the highest sum of the highest sum of the powers the highest sum of the powers of the variables is its degree. Okay. I'll give a small example. Example, let us say your x power 1 minus 5x square plus x power 10. What is the degree of this polynomial?
Sir, 10.
Certain.
Sir, 10.
10.
The highest.
Yeah, highest,
Highest degree.
highest power of x, it is 10. Okay.
So the highest sum.
Power.
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 The term polynomial.
First time it is just the highest power, not the highest power.
No, so in the note.
Yeah, I'll come to the note.
The
Highest sum, the highest sum of the powers of the variables. I'll give an example. What is the degree of this polynomial?
Sir, 5. 5.
Yeah.
Sir, it is 5.
Okay. Now let us just
Sir,
analyze this.
7.
No. See.
No, 5.
Yeah.
So how?
Let me answer. Let me speak. Wait. First term, you have only one variable, and you don't have any y part. See, this is a variable in. This is a polynomial in two variables. This is said to be a function of two variables, x and y. Whereas the first example, this is said to be a function of one variable. Of course, I have not taught functions, so we'll do that some other. But this is a polynomial or a function of two variables. Each and every term has x power something, y power something. It can be expressed like that, isn't it? For example, the first term can be written as 6 into x power 3 into y power how much?
Sir, y power 0.
This is okay. Second term is minus 3 into x power how much?
1.
Sir,
1.
1.
Next term, x power how much, y power how much?
X power 0, y square.
Square.
And
So
5.
then the answer should be 6.
Wait.
X to the power 0 into y to the power
5
0.
to the power 0.
Okay. So this part is clear to everyone. Now you see, you have to compare the sum of exponents of every term. What is the sum of exponent here? 3 plus 0 equal to 3. What is the sum of exponent here?
Sir, 5.
5.
Yeah, over here.
2.
Sir, 2.
0.
Sir, 1.
0.
0.
So now what is the definition saying? The definition is saying out of all of these, which one is highest?
5.
5.
Therefore, thus this is a polynomial. This is a polynomial of degree 5. Is that okay?
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Okay, note this down. I'll give some questions.
Did you check yesterday's test?
Yeah, I have the results. We'll discuss that afterwards. Okay, done.
Yes, sir.
So 1 second.
Okay. Okay.
Yes, sir.
Yeah, it should be a little quicker. Okay. Now, okay, I'll give some examples. It's not just about solving the examples, but they have a inner meaning. Okay. Just remember these examples for the next 2-3 years, and it will be useful. Okay. What I'm going to give the examples are actually some figures. Just wait a second.
Sir,
Yeah.
What is the
sir,
fourth?
what is after the C in
What
the
is after?
first question?
See, after C is A, B, C. Okay, I think you are absent, na? This is a symbol for belongs to. This symbol means belongs to.
Belongs to.
So
Sir,
what?
belongs to.
Belongs to.
Belongs to. And R means the set of real
Real
numbers.
numbers.
Real numbers.
We discussed this in the initial class. Right?
Sir, we knew it from first one. I did not attend it, but I knew it.
Sir, what's the fourth term in the second question?
2gx.
2.
G. Yeah.
So what is the fifth term in the second equation?
2gx 2fy plus 2hz.
Fy. H.
Okay, let us just do this. What is the first answer? Find the degree. Find degree. Find degree of each of these polynomials. First answer.
2.
1.
Degree is equal to 1.
Yes, sir, 1.
And
Yeah.
side point is this is the equation of a straight line. Okay. This is actually the equation of any straight line. And whenever the degree is 1, it is said to be a linear polynomial. I just explained this. Generally, whenever you mean linear, you mean.
Sir,
Yes.
in our book it's given ax plus by plus c is the standard equation of a simultaneous equation.
Oh, that is ax square plus
No, no,
bx plus c.
Yeah. Yeah.
A linear equation. They must have told it is a linear equation.
Yes, sir.
The equation of a straight line. No doubt in that. Second one, what is a degree?
Sir, 2.
Sir, 2.
Sir, 2.
So 2.
2.
Yeah, correct. So, does anyone know what this represents? This actually represents.
Quadratic.
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 See, it is quadratic, but what does the equation represent? Does anyone know? This represents the equation of a sphere. You'll learn in higher classes. Okay.
Sir, we had the basic concept of the
Sir,
straight
2.
line.
Yeah, 2 is the right answer. What Ashmita is saying?
So the first one which we did, that straight line, we had the basic concept because in class 8 we did the straight line on graphs.
Good. Okay, next one, third one.
Sir, 2. Sir, 2.
Sir,
2. Yes, sir.
Sir, 2.
Yeah, correct. And this is the equation of circle. This actually represents the equation of a circle. Fourth one.
The 3.
3.
3.
3.
Anyone has any other answer? Swapnavit, you have some other answer?
No, sir.
Anyone
So
has?
I have a doubt in question number 2. Why you have written the sphere there? Sphere there.
Why means at this point of time I cannot explain because you don't know coordinate geometry. But it represents the equation of a sphere.
So
Just
we had coordinate geometry in class 8.
yeah, but you don't have circle sphere. That's Arctic. So you remember that's what in the future.
So we just had plotting.
Yes,
Yeah,
sir,
if you plot it, you will get a sphere. It is like that. I can explain, but you guys won't understand. Okay, so some other time. This is just like general knowledge as of now. Just remember. What is the fourth answer? Anyone wants to answer?
Sir, 3.
3.
3.
Any other answer? Not a polynomial.
Not a polynomial.
Good, Adrika. You had the same answer.
Yes, sir, I thought,
yes.
but everyone will see that for like.
Good.
yes, sir, because one is having -1,
Yeah.
not a
Yeah, y for minus
y.
1.
Okay, sir.
Fifth one.
The 4.
Sir, 4.
4. Yes, sir, 4.
Okay. Now,
Sir, is that another equation? X square plus y square plus z to the power 4.
no, that doesn't make any shape. But this is something very important. Okay. Let us. I'm just isolating this. Can someone tell me something about this? So this is a point in the space. See, when you're talking about x, you're talking about the number line. All of you know the number line?
Yes, sir.
Yes.
Yes, sir.
We're going along the number line. X equal to 0, x equal to 1. And this time we learned how to plot root 2. Remember, you can even plot root 2. So this is representing the number line. When you have two variables x and y, basically you're dealing with a plane in which you have x coordinate and y coordinate. You have a x coordinate and you have a y coordinate. So when you have two variables, you're dealing with a plane. When you have three variables, generally you're dealing with
3 coordinates.
Coordinates.
you call
3
X,
coordinates.
Y, and Z.
Yes, sir.
so 3D generally refers to space. Okay, there's
Yes,
x.
sir.
Okay. Now anyway, what do I want to discuss about this? See, take a
So
very
before we discuss, may I ask something?
tell me.
So you told in a note that for a polynomial of more than one variable, the highest sum of the powers of the variable is its degree. So in the examples that you gave now only, why are we writing the highest degree only? Why not the sum of their powers of the highest degree?
Sir,
No, see, I'm
That's a
writing the
double
highest.
variable.
I'm writing the highest only. So I'm writing the highest sum itself. See, even if you take the sum, you'll get the same thing, na? X power 2 plus 0 plus 0, y power 0, z power 0. You got it, Srijita?
No, sir.
No, this can be written as x power 2, y power 0, z power 0.
Yeah.
So every term can be written like that, na? है ना? Every
So,
term.
so we can write that x square into y to the power 0, y to the power 0, z to the power 0 plus y square plus x to the power 0, z to the power 0.
So
Like
if you add 0, 2, 0, 0, 2. You get 2 only na, by adding 2, 0, 0.
yeah, but
So that's what we did. Okay.
yes, sir.
Okay. Now coming to this particular example, why is this so important? X square plus y square plus z power. What does this represent? Some of you are asking, what does this represent? Can anyone guess? This actually represents the origin. This is a point called origin. What do you mean by origin?
Coordinate
So
0, 0.
Yeah.
Yes, sir.
So
Coordinate 0, 0, 0.
yeah, see, why does it happen? So see, x square is a quantity which is always greater than or equal to 0. Similarly, y square also has to be greater than or equal to 0. Z power 4 is also something which is always greater than 0. Now, on adding three non-negative quantities, when can you get 0? Can the answer be 0? If you add something non-negative, 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 can the answer be 0?
No, sir.
It
No,
is
sir.
only possible in one case. What is that case?
So
Don't-
when the
When all threes are zero.
when the
All the threes
value
are
of
zero.
all three variables is 0.
That is very important. Important. Only possible. Only possible when x equal to y equal to z equal to 0. Okay.
Yes, sir.
So what does it represent? It represents a point. So the last equation actually is not something 3D, but it is simply a point. Which point? The point 0, 0, 0. Okay.
Excuse me.
You have some doubt here?
Sir, can you explain it again?
The x square is always 0 or greater than 0.
Yes, sir.
Who's putting the dots? Don't do it. If I find you, I won't allow you in the class again. So x square is always greater than or equal to 0. Y square is greater than or equal to 0. Z power 4 is always greater than or equal to 0. But on adding all three, the sum should also be something greater than or equal to 0.
Yes, sir.
So when can it be equal to 0? See, let us consider even if one of them is not 0, if it is something positive, and then even if the other two are 0, 0, then can you get the answer as 0?
No, sir.
So only in one case it is possible that the sum is 0, when all three are 0. Because if it is not 0, then it is something positive. Na? And if you add something positive, can you get 0?
Sir.
Yeah, that's why the only possible solution is all three of them are 0. Is that okay?
Okay. Sir.
Yeah.
Yes, sir.
Okay. Now, okay, so today I'll send some notes where you'll see many useful identities. Already many of you know few of the identities. One second, I'll just share the screen. So this is the notes I'm going to send you today. You're able to see the notes? Yeah. So you just go through all of these things at home. I won't discuss everything today because many of you know many of the things, but I'm going to discuss one particular identity. All of you are comfortable with all these expansions? A plus B whole square, whole cube. Everyone is comfortable with them?
Yes, sir.
Yes.
Yes, sir.
So you just go through that yourself. But today I'm going to discuss something in particular. I'm going to discuss 1, 2, 3, 4, 5, 6, the sixth identity, which is very, very famous and common in competitive exams. Okay.
Yes, sir. Yes, sir.
The remaining you just go through. Anyway, I'll send you the notes. Okay. So the sixth identity which is written as a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Okay. First of all, you guys might be wondering, sir, can you prove this? Answer is you can also prove it yourself. How to
Sir,
prove?
I can prove.
Yeah,
Sir, I can.
anyone can prove. You just multiply these two terms, it will all cancel out and you get this. So this proof you can do yourself at home. Okay. Try proof. Try proof as homework.
Sir,
Yes.
sir, we can in this identity there is another condition, that is if a plus
Yeah, I'm
b
coming into
plus
it.
c is equal to 0, then we can say the equation as the
AQ plus BQ equals to 3 ABC.
ABC.
Yeah. So I'll come to that. Don't worry. Okay. So now, so further inferences. What are the further inferences we can make? First and foremost, if a plus b plus c is equal to 0, then that implies, see, if this part is 0, then 0 into whatever you multiply it is equal to 0. So that,
Yes, sir.
Then the answer will be 3ABC.
yeah, the
Yes,
right
sir.
hand will also become 0. That means a cube plus b cube plus c cube will be equal to 3a.
3 ABC. Yes, sir.
I think, should we check with one example? Let us put a equal to 2, b equal to -1, c equal to -1. Okay. So a plus b plus c is 0. Everyone agrees? So what is a cube? 2 cube plus -1 cube plus -1 cube, which is nothing but 8 -1 -1, which is equal to 6. This is the right hand side. This is the RF. Now LHS. What is LHS? 3 into a into -1 into -1, which is equal to 6. Hence LHS is equal to RHS. Both of them are 6. Okay. So if the sum of three numbers is 0, then we can immediately conclude that a cube plus b cube plus c cube equal to 3abc. Okay. So this has so many questions. There are so many questions you will find on this concept. This is very, very popular, extremely popular. Okay. But before we go into questions, let us go to inference 2. Have you guys copied?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, enough. See, second inference is, what is a plus b plus c whole square?
Sir,
Sir, a square
A
plus
square plus
b
B
square
square
plus
plus
c square.
square plus
Sir, plus
plus 2
2ab
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 2ab plus
plus
2bc
2bc plus
plus
2ca.
2ca.
2 in common, then AB plus BC plus CA.
Yes, sir.
Now you see, in the second part of the identity, you have a very interesting term, a square plus b square plus c square minus ab minus bc minus c. Now just focus on this. This is the second inference. Second inference is saying a square plus b square plus c square minus ab minus bc minus ca can also be written as half into 2 into a square plus b square plus c square. Everyone agrees?
Yes, sir.
Yes, sir.
No one is shocked, surprised? Everyone is in a normal condition. So I'm taking 2 inside. This becomes a square plus b square plus, or see, I'm just rearranging the terms a little. Just listen very carefully, or else you will get doubt again. Okay. Plus b square plus c square minus 2bc plus c square plus a square minus 2c. Can I write it in this way? See, 2 into a square, I'm writing a square plus a square. B square into 2, I'm writing.
We get some formulas inside it.
Yeah.
Yes, sir.
What formula are we getting?
Sir, a square
minus
minus
b-
a minus b whole square
A minus
plus
b,
b minus c whole square plus c minus
A minus
c.
A whole square.
Minus c whole square plus c minus a whole square.
Okay. Okay. So what is the second inference? Hence, second inference is a cube plus b cube plus c cube minus 3abc is equal to half into a plus b plus c into a minus b square plus b minus c square plus c minus a whole square. Clear? Is this clear?
Yes, sir.
Yes,
Sir,
sir.
when we are multiplying the 2, means we are multiplying 2, then it should also be 2a square plus 2b plus 2 square.
See that 2a, that's what I told. 2a square I am splitting as a square plus a square.
Oh,
Okay.
okay, sir.
Everyone is clear?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next, inference 3. What is inference 3? Inference 3 is if a plus b plus c does not equal to 0 and a cube plus b cube plus c cube equal to 3abc.
Sir, can you just go to the previous page, sir? Sorry.
What happened?
Sir, can you just go to the previous page once?
Okay.
Thank you, sir. Thank you very much.
Can anyone try this proof? Take 5 minutes. If someone proves, I'll be very happy. I'll give you 5 minutes. Try it
Sir,
out.
we have to prove that A equals to B equals to C.
When a cube plus b cube plus c cube equal to 3abc and a plus b plus c not equal to 0, then you have to prove a equal to b equal to c. Okay, try it for 5 minutes. I'll come. Oh, Anushrita, you're able to prove?
Yes, sir.
Okay, just wait 1 minute. Okay.
No, sir, I've done a mistake. I have to do it.
ठीक है, fine.
Yes, sir, proved.
Okay, go ahead, tell me. Tell me. Tell me, Anushrita, whatever.
So a cube plus b cube plus c cube minus 3abc equals to a plus b plus c whole multiplied by a square plus b square plus c square minus ab plus bc plus a minus ac plus minus ab plus ab minus bc minus ac. So not half. I have not used half.
Okay, but this is a much simpler way to prove that I'm writing. Okay. Is that
I have
okay?
not. Yes, sir, okay, but I have not proved this in this way.
Okay, let me just do it this way because I'm a little short up. Okay. So this is the identity, all of us know it. Okay. Now, given a cube plus b cube plus c cube minus 3abc is equal to 0. Is this given in the question? Yes or no? Is it given, Anushita?
Yes, sir.
Because from here we can tell that this is 0. See, if this is 0, this is the right hand side. Implies left hand side should also be 0. What is the left hand side? Left hand side has two components. A plus b plus c into half into so on and so forth equal to 0. Okay. See, now you guys have to understand one important thing. If I say a into b equal to 0 and let us say a does not equal to 0, what does that imply? That implies
B equals to 0.
b equal to 0.
So B equals to 0.
Yeah.
Yes,
Similarly,
sir.
here we have a plus b plus c into half of this whole part equal to 0. And in the question it is given that this part is not 0. This is not equal to 0. What does that imply? Implies half into a minus b whole.
Sir, this so the second term is
Equals
then
to 0.
we can say the second term is 0 equals to 0.
Yes, sir, 0.
See, but
And then we can say that a plus b plus c is equal to half into a minus b whole square plus b minus c whole square.
Sir, this will only happen if A is equals to B equals to C.
why? Why?
Because A minus B should be equals to 0 and B minus C should be equals to 0 and A minus C should be equals to 0. Only then we will have the 0.
See, this is just like the previous question I showed you over. X square plus y square plus z square, it is more or less square. Na? Z power 4 is also a form of square. Z power 4 means z square whole square. So somehow square is equal to 0. Equal to 0 is only possible when all of them are 0. Isn't it? If I use the same logic here, let us say this is some x square and this is some y square. This is of the same form, x square plus y square plus z square. Can I say this is of the same form, equal to 0? What
Yes,
does
sir.
that implies?
Yes.
X
But
equals to y
yeah,
equals to z.
yeah. But in this case, what is x? X is a minus b. So a minus b equal to 0 and b minus c.
B minus c equals to 0. And C minus A equals to 0.
Implies A equal to B equal to
C.
okay.
Sir, are you speaking something?
No. Are you guys done copying?
Yes, sir.
Sir, done.
Yes, sir.
Okay. So you can find many examples in the notes I'm going to give. You'll find plenty of examples. For example, there is one particular question. Example 10. Example 10, example 8. I'll give you the notes. You can go through example 8, example 10, which is the application of the same property. Okay. And then yeah, so that is the other parts I'll have to discuss in next class because we are short of time. Okay. So next class we'll discuss reminder theorem, factor theorem, and we'll discuss more about symmetric equations. Okay, because you guys wanted notes before itself, I'll give you the notes. You try to go through and whatever you understand well and good. And anyway, we'll discuss the remaining things in the next class. Okay. So with that,
Sir,
yeah, you have some doubt?
yes, sir, can you send the results?
I'll send that anyway. Okay.
So
Anyone?
can I ask you something?
Yes, ask me please.
So can you send me some notes of modulo?
Yes, surely.
Because it is not clear.
Yeah, it is.
I'm not clear in that part.
No, okay, no problem. See, that is not part of any school syllabus. That is part of Olympiad syllabus. See, I'll send notes, but again, those notes I also will. You'll find many other things. So don't be confused. Just try to understand the basic things in the
Yes,
note.
sir.
Okay.
Yes, sir. Yes, sir.
Okay. Or in fact, if you want, I can show you one particular simple notes right now. I have two types of notes. I have this just basic properties of congruence. Will this be sufficient, or do you want more elaborate questions and everything?
Some more elaborate questions.
Okay. See, I'll send more elaborate notes, but then in those elaborate notes, you'll find many other theorems, which I have not discussed yet now. Okay. So don't bother about that. Okay. Fine.
Okay, sir.
Oh.
Okay, sir.
Okay. So thank you very much. So I'll send the notes via WhatsApp. I'll send the notes of polynomials, of logarithms, because you guys are telling you did not get. As far as I remember, I already gave notes of logarithms. So anyway, I'll give it again: logarithms, polynomials, and congruence modular. Okay. Is that okay?
Yes, sir. Okay, sir.
Okay, sir.
Yeah.
Yes, sir.
Thank you very much.
Bye, sir. Bye,
Yes, sir.
sir.